Hello. This video is going to cover GCF factoring. GCF stands for greatest common factor, and it's going to include the practice set because the lesson itself is fairly short. So I think we can roll the lesson and the practice set into one video. Right now, there's a floor being installed right above me, and there's kind of this incessant, at the moment, pounding. I have no idea if the microphone on the video is picking that up, but hopefully it's not. But if I trip over something, it's because sometimes it gets a little bit loud. Please give this video a thumbs up if you find it helpful. Subscribe for more math help, comment below to engage, and check out the rest of the videos on the channel, especially our factoring videos. So this is the first video in the set on factoring, but factoring will include a lot of things, including some comparisons of different strategies that you can use. Now, to begin with, we want to recall what distribution is. Distribution has a very specific definition in math, and we want to remember what that is. Distribution is multiplication distributed over adding or subtracting. And we want to be clear about that because there are some other things in math that kind of look distributive-ish, but they're not. Distribution is strictly multiplication. So you got 3 times or -2 times, if we look at the two examples there. And that multiplication is happening to a group of terms that are added or subtracted. Okay, that's what distribution is. Now, when teachers are teaching this, typically they will draw in these little arrows. And the arrows are not part of the work process. The arrows are a teaching tool so that students know what to look for. They help track your line of sight. So the 3 is going to be multiplying everything in there. So we'd have 3 times x squared, which would give us x squared. 3 times -3 is -9. And of course the x would be there. So we'd have -9x. And then 3 times 4 is 12. And we would say that the 3 was distributed through or multiplied through the parentheses there. If you are distributing a negative, you want to make sure that the negative gets multiplied through as well. So -2 times 3 would give me -6. And then, of course, the x squared is there. So -2 times 3x squared is -6x squared. -2 times 4 is -8. So you could either write -8x or plus -8x. And -2 times -1 is +2. GCF factoring, the topic of this video, is essentially reverse distribution. So what we are going to be doing is starting here. Okay, so we're going to start here, and then we will end here. Wow, that is very loud. Okay, so we're going to be starting in that bottom line. And what we do is we identify what factors all the terms share or have in common. That's the common part, and the all part is the greatest. So there's your greatest and there's your common. And then we factor them out, and that means to undo the distribution. And that's the vocabulary that we use. So for example, if we started here and ended here, if you see where I'm pointing, we would say we factored out a -2. Okay, we wouldn't necessarily say we undistributed it, even though that's like what we're doing. We would say we factored it out. Now, here's a strategy for factoring out a GCF. A strategy you can use is to get the prime factorization of each term. Prime factorization means that you're going to break it up into all of its factors such that you can't break it up anymore. Okay, you cannot break it. There's no more factors. Identify all of the factors that are shared by the various terms and then factor them out. So we're going to work through 2 examples so you can see what I mean here. In this first example, we have 6. Well, 6 can be factored into 2 times 3. And then we have x squared, which can be factored into x times x. And for clarity, I'm going to use a different symbol, different color there for the operator. 9 can be factored into 3 times 3. And then we'll have times x. And then we'll have the plus sign. Now, here's where it gets a little bit weird. 3 is a prime number. So we could say, well, 3 is already factored as much as it could be. But what I'm going to do is do a times 1. And you might be thinking, well, why did she do that? Why do the times 1 there and not do times 1 or times 1? Well, in reality, we could do times 1, but I want you to think about like whether or not you believe that that is an okay thing to do. So is 3 the same as 3 times 1? Yes. Is 6 the same as 1 times 2 times 3? Yes. Now, we don't really need it for those first two, and you'll see why in a moment, but we do kind of want to have it there for that last one. If you'd like to put it in for all of them, you can. But I'm going to go ahead and erase it because it might muddy the waters a little bit here. Now we go through and identify everything that they have in common. Well, I can see that we share a 3 in common. And what you're looking for has to be common to all of the terms in question. Okay, all the terms in question. Now we will factor that out. And what I say here is we're going to put the rest of it back together. So 2 times x means I am left with 2x squared. Right here, 3 times x means we'll have a 3x. And here's where that 1 comes in handy. If I take the 3 out or factor the 3 out, I am left with a 1. Most common mistake if we don't put the 1 there is that students will say that, oh, we're left with a 0. And that won't work if you try to distribute it back through, okay? It won't work. So it helps maybe visually to have a 1 there. After you've done this a few times, you will remember that if you have something and you factor the whole thing out, that you're left with a 1, not a 0. And the reason why it might muddy the waters is if you end up circling the 1, like for all of them, like you could always add more 1s though. Okay, so bottom line there, if you factor the whole thing out, you're left with a 1. All right, let's take a look at this example. So here we have 2 times x to the third. So x times x minus the 6 breaks into 2 times 3, and then we have x times x for the x squared, and then 4 breaks into 2 times 2, and then we have an x. And now we're going to look through at each of these and see what do they have in common. First thing I noticed is that they all share a 2. And if you stop at the 2, though, you would get a common factor, but not the greatest common factor, because what I also see that they share is an x in common. So my greatest common factor is not a 2 and not an x, but 2x. I would actually multiply them together, and we're going to factor out a 2x. And now we just see, well, what's left over? What will still be there? And we'll put it back together. So x times x is x squared. In the middle here, I've got 3 times x, so we'll have a minus 3x right there. And then it looks like plus a 2. And we would say, again, the vocabulary that we would use there is I factored out a 2x, okay? And this is a pretty foolproof strategy of getting the prime factorization and then identifying all of the common factors and factoring them out. Now, you can and eventually should do this without the prime factorization. So by the time you are halfway through Algebra 2 or in pre-calculus, if you are still needing to find all the prime factors to get your GCF, it's going to really bog you down and make your work cluttery. So looking at this one, we have 4x to the third minus 12x squared plus 8x minus 4. And I'm going to do this one without the prime factorization. Now I've got x's here, x's here, x's here, and no x's down here. So what that tells me is that x, there's no common factor of x. Does not matter if these 3 share it. If there's no x down here, then it's not common. So that means I'm free to look at just the numerical part. I've got some 4s. That means I can't have any common factor greater than 4. And I might want to check, can I factor a 4 out of a 12? Yes. Okay, 4 times 3 would give me 12, so I could factor out a 4, I'd be left with a 3, and I can get a 4 out of the 8. If I couldn't, then I might try, say, a 2. Can I get a 2 out? Well, I could, but we want the greatest common factor. So I'm going to factor out a 4 and then ask myself, well, what's left? If I have 4x to the third and I factor out a 4, I'm left with x to the third. Now, here you might want to think of it in terms of multiplication. 4 times what would have given me the 12? Well, that would have been a 3. Okay, so you can almost use the multiplication. 4 times what would give me the 8, because we are reverse distributing, and that would be a 2. And then here, sometimes if you think, well, I have a 4 and I factored it out, so I'm left with nothing. Okay, but think of it this way. 4 times what would give you the 4? That would be a 1. And so typically when you're factoring out a GCF, you are not going to want to show all that prime factorization. Now, GCF factoring is always the first step in any factoring problem. And if you're studying factoring at a higher level, you probably get used to this, or you kind of ignore it after a while. But anytime you are asked to factor anything, the first thing you want to do is look for a common factor. Even though we kind of stop talking about it and you say, oh, go ahead and factor this, or we get so wrapped up in other strategies for factoring that I feel like my roof is going to cave in. This is nuts. I'm so sorry if the video is picking it up. And if it's not picking it up, then I sound like I'm nuts because it's just really loud here. Anyway, GCF is always the first step in any factoring problem. So looking at this one here, okay, I see the 6 and I see the 54, and I know that 6 is common to both. So I would factor out the 6, and that would leave me with x squared minus 9. Now I can check that with distribution. 6 times x squared is 6x squared. 6 times 9 is 54. And then we talked about this in a previous video. That is the difference of squares, and you can figure out what was multiplied. So if you looked at the previous practice set, there were a couple questions that say, hey, what was multiplied to give me this? And what was multiplied are these things called conjugates. And it would be x plus 3x minus 3. So you might want to check out the previous video on special cases of multiplying binomials, just to kind of see what this is about. So go check that out. It's on the playlist. But anyway, GCF factoring would always be your first step in any kind of factoring problem. Okay, so this is the practice set. So normally in a practice set, I would say pause the video right here, and I want you to work all of these problems on your own, and then unpause the video to check your work, and we'll kind of go over them together. All right, so hopefully you did that while I was sitting here waiting for about 5 seconds. It wasn't super noisy upstairs, so a little bit of a break, maybe, sort of. Okay, so looking at this now, I'm going to use the prime factorization on this just to drive home the factorization piece. So this is 2 times 3 times x plus 3 times 5 times x. So breaking it down into those prime factors. What we have in common, well, I see a 3 in common and I see an x in common. So my greatest common factor would be 3x, and I am left with 2x when I multiply that together, and a 5. And so the greatest common factor, getting that GCF out, would be 3x, and I am left with 2x plus 5. You can always check that by distributing. So your check for this is, let me go multiply it back through and see if I get the original problem. On this one, we have 9, which factors into 3 times 3, and then we have x times x, 54. Okay, going to do a little bit of work over here. That would be 9 times 6, and 9 factors into 3 times 3, and 6 factors into 3 times 2. So that is 3 times 3 times 3 times 2 times x minus 3 times 3. Well, what do we have in common? We've got 2 3s. So I see 2 3s, and I think that's it, okay? So our GCF would be 3 times 3, or 9, and I'm left with x squared plus 6x. So you want to put that back together, 3 times 2. And then right here, remember, if you factored everything out, there is a times 1 out there. Okay, so you are left with a 1 and not a 0. Next one, what do we have here? We have 2 times 2 times x plus, and then I'll come over here and just do a little bit of scratch work. The 24 factors into, we'll do 2 times 12, and 12 factors into 2 times 6, and then 6 factors into 2 times 3. So that is 2 times 2 times 2 times 3. And what I see that we have in common is 2 2's. And 2 times 2 is 4, so my GCF is 4, and I am left with x plus 2 times 3 is 6. And you might be able to do that one in a much shorter way. So you might say 4 times 6 for the 24, and then just grab the 4 at that point. So remember, the idea is that you would eventually do this without doing the prime factorization. So for this next one, we're going to take a look at this one. We've got 12x squared y plus 9xy squared. My students don't like it when I throw something at them. They're like, you didn't do one that had an x and a y in it in class, and you gave it. Yes, I know. But if you understand the concept and you believe that the strategy is working, then it doesn't matter if the problem looks a little different. You should still be able to do it. So for 12, we'll do a little bit of work there. That could factor into 3 times 4, and then 4 factors into 2 times 2. So we have 3 times 2 times 2. X squared is x times x, and then we have a y. And 9 factors into 3 times 3, and then we have an x, and this time we have 2 y's. And we're doing the same thing. We're going to look for what do they have in common. So we have a 3. I see that they have 1 x in common, and they have 1 y in common. So my greatest common factor is 3xy. You just multiply those together, and you just got to see what you're left with. So 2 times 2 is 4x, and then we have our plus sign, and then I have a 3 and a y. So there you go. It's 3xy, and then in the parentheses, 4x plus 3y. Hopefully you made some progress with that. You didn't let the y throw you off too much. All right, and for number 5, we've got 3, and then we have 3 x's there. The 12, I just did the prime factorization on 12. That's 3 times 2 times 2, so we're not going to reinvent the wheel. 6 factors into 2 times 3, and then we have the x. So what do we have in common? I see that we have a 3 in common, and we have an x in common. I think that's it. So my GCF in this case is 3x, and then putting the rest of that back together, we have x squared plus 4x minus 2. Okay, so there's our 5 examples, and hopefully you had some success with that. And if you're able to do it faster, you're able to do it without doing that prime factorization, that's great. I always tell my students, do the prime factorization for as long as you need to, okay? And that's going to be different for every student. So some of you might be able to jump right to, I don't need to do the prime factorization, that's a silly step. And some of you might be doing this for a long time, looking for that GCF to get it out. It's important that you're doing this the best way for you. Okay, so that's it. So we're able to do this in less than 20 minutes. Like and subscribe if you found this video helpful, and I'm going to apologize for the side noise. It's quiet at the moment. Drop a comment or question below, and check out the other videos on the channel, including the series of factoring videos and the comparison of factoring methods. I'll try to link those around, or just check out the playlist on the channel for those. I hope you found this helpful, and I will see you in the next one.